Hello, good morning, everyone. So today we will be tackling about related rates. So let's begin. So for our first problem, we have an ice cream cone of radius 4 centimeters and height 16 centimeters is dipped first in a 6 centimeter radius cylindrical container filled with chocolate. How fast is the chocolate level rising if the ice cream cone is dipped halfway and has been steadily being dipped at the rate of 3 centimeters per second? So first we need to define our variables so we don't get confused as we're solving this problem. So we let V sub I be the portions in centimeters cubed of the ice cream cone that has already been dipped. And we let V sub C, the amount, be the amount of chocolate in the cylindrical container in centimeters cubed added to V sub I. And lastly, we let L be the chocolate level in centimeters. So since we are asked how fast is the chocolate level rising, what we want to find would be dl all over dt. So since the amount of chocolate remains constant for this problem, we know that d times v sub c all over dt is equal to d times v sub I all over dt. So note that v sub c, which is the volume of our chocolate in the cylindrical container, is basically just pi r squared L. So we know that the radius is 6 centimeters. So we derive this equation so we can get d times v sub c all over dt, and we get it is equal to pi times 36 centimeters squared times dl all over dt. So let us check the figure below to see what happened in the cylinder and the cone. So in the figure below, we have BC to be 4 centimeters and AC to be 16 centimeters. So we let H be equal to AE and R to be equal to DE. Oops. Since that is the cone part that we dip into the chocolate. So here is the original and here is the displaced. So by triangle similarity, notice that BE all over AE is equal to BC all over AC. So we have R all over H is equal to 4 all over 16, which means that R is equal to H all over 4. So at a given time, V sub I is equal to pi all over 3 times R squared H. Substituting the value of R we got earlier, we will have pi all over 3 times H all over 4 to be squared times H, or simply pi all over 48 times H cubed. So we derive this equation. So in order to get d times v sub I all over dt is equal to pi all over 16 h squared times dh all over dt. Since it was given that the ice cream cone is dipped halfway, we let h to be equal to 8 centimeters, which is half of the height of the cylinder. And because the cone was steadily being dipped at a rate of 3 centimeters per second, we know that dH all over dt is 3 centimeters per second. So we substitute that um, by combining every equation that we have so far, we will get pi times 36 centimeters squared times dl all over dt is equal to pi all over 16 h squared we multiply by dh dt. So substituting h and dh all over dt and solving this equation, eventually we will get 1 dl all over dt is equal to 1/3 centimeter squared. And we are done since we are looking for the rate of the chocolate rising as we dip the cone. So let's move on to problem number 2. You're minding your own business when suddenly a clown 17 meters south of you starts miming towards you northward at a rate of 3 meters per second. Due to your fear of clowns, you scream and start running eastward at a rate of 5 meters per second. If you and the clown continue on the same direction, how fast is the direct distance between you and the clown, changing 3 seconds after you started running? So let us analyze the problem. So it said the question is asking how fast is the direct distance between you and the clown changing 3 seconds after you started running? So we have to multiply the rates we have by 3 seconds in order to get our distance. So have 3 meters per second squared times 3 seconds is equal to 9 meters. That's how far the clown has traveled towards you. And you have traveled 5 meters times 3 seconds, which is 15 meters away from the clown. This means that after 3 seconds, the distance from the clown's current position and your initial position is 8 meters. Simply 17 meters minus 9 meters. The figure at the next slide will illustrate this. So it's better if you draw these kinds of problems so you have a better idea on how to solve it. So here we are at t equals 0 seconds. We are here in our initial position and southward 17 meters, we see a clown. After 3 seconds, we run here and we have reached 15 meters as the clown is going closer to our initial position, and the distance between that is 8 meters. So notice how this looks like a right triangle. And you are right. So using the Pythagorean theorem, we can easily solve for our 30-second mark. So r squared is equal to h squared plus y squared, which is equal to 289, which means that r is equal to 17 meters. So we derive our Pythagorean theorem. So we have 2r times dr all over dt is equal to 2x times dx all over dt plus 2y times dy all over dt. So notice that you go farther from your initial point, meaning your distance from your initial point increases. Thus, dx all over dt is greater than 0 since we are moving to the right from our initial position. Moreover, we observe that the clown approaches your initial point, meaning that the distance between the 2 points is decreasing. Thus, dy all over dt must be less than 0. So recall from the given earlier that we were moving 5 meters per second to the right. So that is our dx all over dt. And the clown is moving 3 meters per second towards our initial position. So that is our dy dt. And what we want is our dr all over dt. So putting everything together, we will get this, and after solving that, eventually we will get our answer. So dr all over dt is equal to 3 meters per second square. Hence, the distance between you and the very scary clown is increasing at 3 meters per second. So that is all for our exercise today. Hopefully, you were able to learn something and you are now prepared to tackle your exam. Thank you for listening.